Yep, and we do record the sessions just so we can send out the recording later to folks who signed up. Welcome everybody to another great monthly webinar here with NextUp Solutions. I'm Dr. Patrick McConnell. If we haven't met yet, let's go ahead and begin with some introductions. This is me. There's way too much stuff on this slide, but I put it all in one place so that you can forget it quicker. I am Dr. Patrick McConnell. You can call me Mack, because my PhD is irrelevant to everything we're going to talk about. I've been an Agilist for what goes for a long time in this business, actually close to 15 years now. I should update this slide. I started off my Agile journey as a product owner, building mapping tools for government agencies. Then I became a Scrum Master for a while, and then I became a full-time Agile coach for a bunch of years, ultimately becoming the director of the Agile Center of Excellence at one of the gigantic government-focused system integrator companies in the DC area. And for most of that time, I was also pursuing becoming a Certified Scrum Trainer and joining the Scrum Alliance Guide community. I finally did that in 2018, and since then, I mostly just get to do stuff like this all the time, teach classes and make grown-ups play silly games, and that's a lot of fun. Let's see. As for us, we are actually two entities, NextUp Solutions and Acceleration, and I know we have a couple folks joining us from both of those today. That's great. Acceleration is our software development practice, where we build all sorts of great world-class leading software applications for all sorts of different customers. Operating in kind of an interesting model, what we tend to do is we hire college students as they're finishing up degrees in things like computer science. They then come to work for us part-time in between their classes doing real software development at real organizations, but under the guidance of our expert mentors who teach them that craft and keep them from blowing anything up. The companies that hire us get fantastic work done at great rates. The students get amazing experience, which lets them go off to fantastic careers after they graduate. Ends up being kind of a win-win-win for everybody. So we're very proud of what we do at Acceleration. If you've got any questions about it, by all means, reach out and I will connect you to people who will gladly tell you all about it. As for NextUp Solutions, we are a certified Agile training provider operating in the DC area, but serving people globally at this point, thanks to the pandemic. We run all sorts of live taught, expert-led, engaging, games-based certified Agile training, lots of Scrum Alliance courses, also Kanban University, some IC Agile, and then a host of customized tailored offerings for folks that need those as well. And we are a full-service Agile coaching and collaboration practice. So that means everything from traditional embedded team coaching, helping new Agile teams get up and running or helping existing ones get better, to helping whole enterprises plan out or improve an Agile transformation at scale. And then the third leg of that practice is our Agile leadership development work. So helping bosses grow into Agile leaders is a very important part of what we do in our coaching practice. So that's what we do there. And if you have any needs in that area, again, by all means, reach out and I will be happy to tell you all about it, figure out how we might assist you in your Agile journey. All right, so that is us. Let's go ahead now and get rolling with the stuff you're actually here to see. We're going to talk about release management with Agile estimation today. And really, we're going to kind of do this talk in two parts. Up front, I'm going to talk a bit about how relative estimation on Agile teams tends to work. And then I'm going to talk about how we can use those estimates to plan and manage releases. We'll save some time for questions at the end. Of course, if anything I'm saying as we go is not clear, feel free to ask or raise your hand as we go through. All right, so let's dive in. Typically, most Scrum teams and generally Kanban teams too work from some kind of a product backlog. That's generally really just a list of all the work that a team might do to support some larger product goal. If we were talking about, say, a Scrum team that's building some brand new application from the ground up, I would expect that a lot of what's in that product backlog are features, capabilities that we want to exist, results that we expect to happen when somebody flips a lever or pushes a button or whatever it is. And again, if this is a brand new thing that we're building from the ground up, that's probably most of what's in a team's product backlog, probably 70% or more. There could, though, be a bunch of other types of thing in the product backlog too, still related to the product goal and delivering value, like fixing bugs that escape to production that we just discovered, or purely technical work that we need to do to enable us to do something else, like fix a bug or build a feature, patching a server, things along that line. And then we could also have knowledge items in a product backlog as well. These would be questions that we want to answer as a team, because that'll allow us to go on and do one of the other types of product backlog item. So for example, a knowledge item might be something like, should we make or buy a particular part of the solution? If we wanted to make our own, do we even know how to do that? And the knowledge item might be, let's do a quick proof of concept before we invest a bunch of time into something that turns out to be not technically possible or something like that. So at any rate, product backlogs could have any of those types of thing in them, and that might be obvious to you. If so, awesome. It's not obvious to everybody, and that's why I have to tell them this. In fact, sometimes teams get told a very unhelpful thing. Sometimes teams get told that the product backlog is only for features. Uh-oh. When that happens, the natural result is they end up with one official backlog where features live and 20 invisible backlogs where the rest of their work is, and now no one knows what's going on anymore. So that's a big problem. So if it's work, we want it to be in one backlog so we can see it. And generally, if we're talking about a Scrum team, they've got a product owner whose whole job is to be managing and owning that backlog all the time. So our goal is we want the backlog to be deep, which is a mnemonic that I think comes from Bill Wake. I'm not actually sure on the attribution there, but at any rate, detailed appropriately, estimated, emergent, and prioritized. That is a good product backlog. So detailed appropriately means the stuff at the top of the backlog, the most important stuff that we're likely to do soonest, is the best understood by everybody. If it's farther down the list and it's something we might not get to for a long time, well, then our understanding can be vague. We might have some big questions. But if it's at the top of the list and we're likely to do it in the next sprint or two, we should have a very good shared understanding of what that thing is. So that's detailed appropriately. Estimated is sized, because sizing is a really important tool for Agile teams, both for planning purposes, like we're going to look at today, also because it supports backlog refinement. If a team can't estimate a thing, that's a clue that we don't agree on what it is yet, or we don't understand it. Emergent means that we keep the backlog up to date. When we learn something new, when we get feedback about changing product direction, or that users don't want this anymore, they want this other thing, whatever it is, that we are reordering the list, that we are removing items that are now obsolete, we are adding new items, whatever it is, all of that would be emergent. And then the last item there, prioritized, at least in a Scrum sense, means that we are doing the most valuable work soonest. So that the list is ordered primarily based on business value or mission value, not based on kind of nat kind of issues of technical interdependency and things like that. So let's zero in then on that emergent bullet, because that's, excuse me, the estimated bullet, because that's so important. Why do we bother estimating on Agile teams, especially Scrum teams? Well, probably for reasons that you would expect, like if we have an idea about how big backlog items are, and we have an idea about how fast we've been going lately, sprint to sprint, that can help us make a good guess as to what'll fit into the next sprint's worth of time. Also, a busy product owner might want to think about estimating as one input into their prioritization calculations. If two things have about the same value, if I need them about the same, I think it's perfectly reasonable for a product owner to say, let's do the smaller one first, because that preserves capacity for other value work too. Finally, we can also use it to set expectations out into the future, and that's really the main thrust of what we're talking about today. How can we guess at when are we going to finish some stuff? If we know about how big all the things are in that set, we know about how fast we've been going lately, we could make a reasonable guess as to how many more sprints we might need to reach that higher level goal, whatever it is, like a release. Okay, so all of that aside, There are some downsides to estimating too. Does anybody happen to know, what does the word estimate mean in a dictionary sense? What is the literal definition of estimate?
Guess.
Yes, that's exactly it. Thank you, Joe. Yes. Estimate and guess mean exactly the same thing. The problem that teams have sometimes, though, is that they say something like, we estimate this backlog item is going to take, or is about whatever estimating system they're using. And they mean we guess. But the person they're talking to hears them say that and interprets their words as, our scientifically informed promise is. That's not it. When estimates, which are guesses, start getting treated like promises, and especially if teams start getting beaten up because they're guesses and not promises, really bad things happen to teams. We very much lose sight of realistic planning. All sorts of bad things happen. So there's an entire movement in the Agile community going back a number of years now called no estimates, where folks advocate not doing estimating at all. Actually, they say things like, as a team gets good at backlog refinement, and the product owner and developers get really good at negotiating what is a backlog item, they just tend to create ones that are smaller in size anyway, and less variable, and more likely to be well understood and fit into a sprint, which means we don't need to estimate. We can make a reasonable guess about what'll fit into a sprint by just counting. Like, we normally do about 6 backlog items a sprint. So which 6 backlog items do we want to do next sprint without bothering to estimate, because we don't need to. So the no estimates folks, I think, make a lot of good points. And certainly I think it's worth experimenting with if you feel like the way estimating is happening on your team is not very useful. Having said that, as I said a minute ago, I think estimating is a really useful behavior for teams, partly as a sidelong accompaniment to backlog refinement. Also, most of the teams I've worked with throughout the years as a coach have been surrounded by some assumptions and constraints that wouldn't let them not estimate if they wanted to. So most teams I work with don't really have a choice about whether to estimate. It's baked into the foundational assumptions of how they were hired, or the charter for their project, whatever it is, things like that. So that's why I think it's worth talking about how to do estimating well. Let's start with a little review. If we're talking about a Scrum team here, we have 3 accountabilities on a Scrum team. We have developers, a product owner, and Scrum Master. Which of those 3 parties does estimating on a Scrum team? Does anybody happen to know? Where do estimates come from?
Developers.
Exactly right. Yes. The people doing the work, the developers, have to own the estimate. Not their boss, not some other team, definitely not marketing. The people doing the work have to own the estimating because they have the technical know-how, not anybody else. They're the closest to the work. The other 2 roles, though, on a Scrum team do play a part in estimating too. A Scrum Master's job is not to do the estimates or tell the team what they should be or force norm them or something. It's to coach them for realism. That means things like making sure every developer's voice is heard and that we're thinking about all aspects of getting a particular backlog item all the way to done when we estimate it. So when the developers are estimating a thing, that estimate should include how much work to create the thing, but also how much work to validate the thing, how much work to document the thing, I don't know, push it to release or whatever's in their definition of done, things like that. Also, Scrum Masters often play a role in estimating as the institutional memory of the team. So reminding a team, for example, hey team, the thing that we just estimated as being really small reminds me of a thing we thought was going to be really small 5 sprints ago, but then it blew up in our faces and it turned out to be really big and horrible. Is this like that or not like that? Now, the developers still own the answer. They might come back and say, no, Scrum Master, thanks for that reminder, but we're very confident this is small. This is totally different. Oh, okay. Or the developers might say, ooh, good point, Scrum Master. We'd forgotten about that. Let's go back and talk about this some more. remembering that hard lesson we learned all those sprints ago. So that's what I mean by coaching. The product owner's role in estimating is not to do it to the team. They're largely a consumer of estimates, again, in ways we're going to look at in a little bit here for planning purposes. But also, product owners often have a role explaining estimates to people outside the team, like stakeholders who want to know when they're going to get stuff. And often they're having those conversations with the product owner. So it's useful if the product owner can explain to them why one particular thing that they want is easy and some other thing that they want is really hard. Now, if you don't have a lot of experience on a Scrum team, but you know a little bit about product owners, you might be wondering, where would a product owner get the technical know-how to explain to someone outside the team why one thing is hard and another thing is easy? Being a technical SME is not the job of the product owner. They're supposed to be the business and product SME. Well, they would get that understanding by talking to the developers all the time. That's one of the reasons we put them in a team together, so that they talk every day about the work, they build up the shared understanding and vocabulary about what is to be done. That's where the product owner will get that context. So anyway, that's who does the estimating on a Scrum team. Having said all that, the thing that makes estimating in Scrum a little weird is we use these intentionally fuzzy estimating methods. And the reason that they're fuzzy is because we are far more concerned with accuracy than we are with precision. And before I explain the difference, or explain why that is, let's make sure we understand the difference between those two terms. Accuracy is, was it a good estimate? Were we right? Precision is, how specific was the guess? So if you think about shooting arrows at a target, accuracy is, did you hit the bullseye? Precision is, how wide is the arrow compared to the little bullseye? It's much easier to be accurate with a telephone pole wide arrow than it is with a needle. Even though did you hit the bullseye is still the criterion for accuracy. And estimates could be both accurate and precise. They could be one and not the other. They could be neither. Some examples, something that is hopefully both accurate and precise is what my employer reports to me every year on a little W-2 form that I get in the mail. So I get this little postcard with a bunch of dollar amounts on it. They all need to be very specific. They're all precise to the penny, but they also need to be true, or else I'm going to get in trouble with the IRS. So those numbers need to be both specific and true, so precise and accurate. Another number that's fairly precise, but not necessarily accurate, is what my driver's license says I weigh. It's a very specific 3-digit number. When I went to the DMV to get a license, they didn't ask me to stand on a scale. They just ask you, what is your weight? And they accept whatever number you give them, as long as it's remotely plausible. Now, I probably gave them a realistic estimate at the time, within 5 pounds, give or take, or whatever I thought I was that day. That doesn't mean that the number moves in my wallet as I change day to day, and I could guess which direction I've gone since I gave them that estimate, but still, it's a very specific number. It's very precise, just not necessarily accurate. Something that is not necessarily accurate or precise would be Comcast says, we will be at your house between 8 a.m. and June. And then they still miss the window. Big, imprecise guess, huge range, still often wrong. Doesn't really do us any good at all. So we want to be up here with something like complexity points, story points, t-shirt sizes, whatever. Some kind of Agile estimate that's good at being accurate, not necessarily precise. So why not both? Why are we more concerned with accuracy than we are with precision? Well, because it turns out that inherently creative and elaborative endeavors like software development, we can't actually do both. If you look at the computer science literature, going back 30 years now on this topic, it's very well studied. and you read the meta-analyses of all the studies about estimating software development versus how long it actually takes, overall, the correlation in general between estimate and actual as a function of how much time we spend coming up with the guess looks like this curve. Where best case, if we spend about half of our time doing estimating, well, we might generate estimates that are roughly 50% correlated to the actual amount of time it takes us to build the thing, which means that the guesses are only off by plus or minus 100% of whatever the guess was. And to come up with those numbers that were only off by plus or minus 100%, you have to spend half of your time estimating instead of building stuff. That is so much time and effort to spend for numbers that are still not good enough to be worth anything for planning purposes. If that's true, and it is, how did we ever make waterfall project schedules that were true in the old days before Agile stuff? Anybody know?
We didn't.
That's right, we didn't. And thank you for being brave enough to say it out loud. Yeah, we basically have just been lying for forever. That's it. I would go to someone like the people I might hire if I win the work after I propose the schedule. And I would give them a bunch of specifications and I would say, how long do you think it'll take you to build this thing? And then they would think about it for a month, come back with numbers in the thousands of labor hours. And I would take the most pessimistic guess and multiply it by, I don't know, 3. That's it. The euphemism for that, by the way, is management factor. Oh, there's some management factor in my schedule. That means nobody knows anything. We just make stuff up. So what we want to do is not pretend that we can actually know this stuff up front, because we can't. We're always doing things kind of for the first time. Instead, what we're going to do is back down a level of precision, because we can be more accurate if we get less precise. The reason this is so hard, by the way, is because when we talk about sizing or estimating, often we use that word as a synonym for effort. How long do you think this is going to take? What do you estimate it as? How many days? How many hours? But because we're always doing new stuff, it's not just effort that's going into that guess. It's also complexity and risk. So effort is, how long do I think this is going to take? Complexity is, but how many guesses am I making in that effort assumption? And risk is, how much bigger could this be if some of the guesses are wrong? It is really, really difficult for human brains to parse out those 3 dimensions about a new task in any kind of meaningful and reliable way. If we could, it might feel like this. Let's say you have a software team that's asked to do 2 things: build a new feature and patch a database. Let's say, well, how long do you think the feature is going to take? Well, it sounds kind of like a feature I built last year. That took me about 2 days. I guess this will take me about 2 days. How about the database patch? I just have to run the script for 15 minutes. Oh, okay. I guess the database patch is smaller. But what about complexity? What assumptions are we making? Well, the feature, like I said, it's a lot like something I built before. There is one new part of it, though, that I'm going to have to figure out. The database patch, on the other hand, I just run the script for 15 minutes, assuming that our current configuration is compatible with the patch. Well, what does that mean in terms of risk? You know, if I'm wrong about how easy the feature is, maybe that adds another day. If I'm wrong about database compatibility with the patch, though, we have to upgrade from Oracle, whatever we're on now, to Oracle Next. Then we're going to have to do all this regression to figure out if that breaks anything. End to end, that's probably a month and a half of work. So the new feature is maybe 2 days, but maybe as many as 3.5. Okay. The database patch is either 15 minutes or it's a month and a half of work. Yeah. we should give a much bigger size to the database patch, primarily for reasons of complexity and risk. So when I talk about accuracy versus precision, what I mean is it is really difficult to look at these two items and say in any kind of mathematical way, how much more work is the database patch? How many times more? But it's easy to look at the two things and say, probably more. We can just say more than, less than. And those kind of ranking comparisons, it turns out, are all we actually need to plan reasonable sprints and set realistic release notions. One problem, though, before we move forward, is that a lot of the scales that Agile teams use, the most common one is the story point scale, tend to look like numbers. They're ranking methods, but the names of the ranks happen to be numbers. People think they know how numbers work. So let's say you've got a team using story points to estimate work, seems to be going okay for them. One day, someone they've never met before is going to walk up and say, hi, I'm from your program management office, and I've been looking at your metrics, and I have some questions. Uh-oh, I should warn you that no fun conversation starts with the sentence, I'm from your PMO, and I've been looking at your metrics, and I have some questions. But anyway, what do you want to know? Well, you've got 8 people on this team. Yeah. You do about 40 points a sprint. Yeah. Your sprints are 10 business days. Cool. Now I know the point to time conversion. Looking at your tool, I know you've got 593 points left in the release. I now know what day and time you'll finish. And if I add more people to your team, you'll get there faster. Wait, no, that's not how any of this works. That's stacking like 17 misapprehensions on top of each other. No, if that team actually bothered to keep track of the total amount of hours they spent on tasks inside of a particular backlog item compared to its story point size, that team would probably see a relationship like this, where at the low end of the scale, things are small and they tend to always be small. They don't tend to ever get big. But as we go up the scale, there's more uncertainty, there's more complexity, there's more risk. That means that the range of how big a backlog item is in total amount of actual effort, the range gets bigger and bigger. And sometimes an 8 might take longer than a 13, which is why we can't do too much math on these. If this team calls something an 8-point backlog item, they're not saying it's going to take them 4 times as long as a 2. It's too much math. What they are saying is if they call it an 8, it's usually going to take longer than a 5 and less than a 13. And if that fuzzy relationship is usually true, it turns out that's all the precision we need to make a reasonable guess as to how many things will fit in a sprint, how many sprints we might need to finish a release. All right, so that's a little bit of insight into how these fuzzy estimations work. There are all sorts of estimating choice sets out there. The most commonly used one is the story point scale that I showed you before. It's a modified Fibonacci series where each number in the set is sort of the sum of the 2 numbers before it. There are some differences from real Fibonacci. I think that one gets picked most often, not because it's inherently better, but a lot of times people don't know they have a choice. Like they don't know that there are other scales, or they're forced to use story points by the tools that they're using, like, you know, Rally or Jira or something is making them use points and they don't know how to change it, or the tool won't even let them change it, whatever. A similar one would be something like the doubles scale, where each number in the set is twice the number before it. Other teams like t-shirt sizes. It's generally still easy for teams to plan a sprint with t-shirt sizes. It can be harder to set a longer term expectation, like how many sprints to finish a release. Because while I don't want people to do too much math on the story points or the doubles, I can't really do any math at all on the t-shirt sizes. So beware. But on the upside, nobody else can do math on the t-shirt sizes either, which is kind of a strength in and of itself. In fact, there's another Agile method out there in the world called Crystal, been around a long time, started by Alistair Coburn. The estimating scale in Crystal is Cherry Football 5 Camaro Mammoth, expressly chosen so that no one can look at those sizes and make assumptions without talking to us. That's the entire point of that scale. Anyway, whichever one you pick doesn't really matter. Often the harder part for teams is getting started with estimating. And to do that, what I'm going to do here is we're going to do a quick little game with some animals. I know that there's a webinar right now. All right. And here's what we're going to do. I'm just going to ask for a volunteer. I want people to go one at a time. And I've got a bunch of pictures of animals here in the middle in a pile. I'm going to start by just putting one of them down on the surface here. This is a goldfish. Okay, these are goldfish. What I want us to do is estimate these things in terms of how much of a hassle are they to own. Okay, so can I have somebody volunteer real quick? Manny, thank you very much. This next thing is a hermit crab. Do you think a hermit crab is easier or harder to own than a goldfish, and why?
Harder, because you have to feed it differently, I think. Well, it's been a while. You have to feed it different flakes. So
Okay.
feeding's a lot more work, and it's a dry terrarium, so you can't just dump it out. You have to kind of do more cleaning.
Okay, cool. All right, thank you very much. All right, the next volunteer. Vanessa, thank you very much. Okay, are you okay with the rank order of goldfish and hermit crab, or would you like to change a thing?
I'm fine with that order.
Cool. All right, then. So if you're cool with the existing order, where would you put kitten in this list? Is kitten easier than both, in the middle, or harder than both?
I would say personally harder than both, just in terms of personality.
Okay. All right, so that's our ordering right now. Thank you very much. How about another volunteer? Nina, are you good with the existing order of goldfish, hermit crab, and kitten?
Yes.
Great. Then where would you put wolfhound? This is the tallest breed of dog.
I would put it above kitten.
Okay, put that there. Thank you, Nina. Next volunteer. Marco, are you good with the existing order?
Existing order is good.
All right, where would you put turtle? This is a red-eared slider turtle, if that helps.
It does help. Between the hermit crab and the kitten.
Okay, all right. Lenora, you're next. Are you good with the order of those 5 things?
Yes,
All right, where would you
I
put
am.
rabbit then?
the rabbit. I've personally owned one. Probably between the cat and the dog.
Between the cat and the dog. All right, cool. Thank you
Yeah.
very much. Next volunteer. Nina, go ahead. Go ahead.
I would put the guinea pig probably under cat, but above the turtle.
Okay, there we go. And then the last one here, this is a Chinese crested hairless dog. If you weren't sure, that last one is also a dog. It is a toy breed. Where would you put that one? Can I get one final volunteer? Candace, go ahead.
I'll just put it between the rabbit and the huge dog.
All right, there we go. Yes, that particular one, by the way, was mine. His name is Squeaky. I put him in there because not many people have experience with Chinese cresteds, and also because it's funny to listen to people talk smack about them when I reveal that it's mine. But anyway, all right, cool. So now we've got our list of animals, and I'm going to distribute them a little more evenly across this spectrum from easy to hard. And if we were a real team ranking actual backlog items, believe it or not, it wouldn't take us much more time than that. What we would be doing is having a conversation as we went about what went into the hassle of ownership, like, oh, this one's more work, but this one costs more money. And we would discover all of these different dimensions that we wanted to pay attention to. Then what we could do is apply some sizing boundaries. So here I've got boundaries for the complexity points. And what we would do is take this first boundary, the smallest number, which is 1 point, and put it in front of whatever we just decided was the easiest thing. And then we could go and take turns like we just did a second ago, going one at a time. Whoever goes next. If you think the hermit crab is harder than goldfish, you put 2 there. If you think that really they're pretty similar, but the turtle's a lot harder, we could put the 2-point boundary there. The next person could either place a boundary or move a boundary. So maybe the 3 start here and somebody else says, you know what, I think turtle's a much bigger jump. We're going to put 5 there. And we're going to put 8 over here. I think this is a 13, and I think this is 20. And we just do that until we had sizes for everything. We don't have to use every size. We don't have to go all the way up to 20 if we don't want to. If we wanted to use a different scale, like t-shirt sizes or doubles or whatever, you could do exactly this same method. But the point is, when we're done, we've established a relative sizing for all of these things, and we know what they are. And then we could just use these existing ones as guidelines to size anything else or new that comes into our backlog as well. If we call something a 13, doesn't mean it's 13 times as much work as this goldfish. It just means there's probably more work than these 8 points, maybe less than this 20. So we're going kind of fast here and at a high level, but in general, that's basically how estimating works on a team. We would discover within ourselves which things do we need to pay attention to, which aspects bump up an estimate. If there's uncertainty, we might increase its estimate. If we don't know what kind of turtle this is and how hard that is to take care of, maybe we move it up here for reasons of uncertainty. That's okay. Or we refuse to size it until we've done more research on what kind of turtle it is and feel like we know. That's also okay. But the estimates are both a planning tool and a way for us to start uncovering those unknowns. So at a very high level, that is a nutshell version of kind of how the relative estimating works on an Agile team. From here, what I'm going to do is talk about how we can then use those estimates, even though they're fuzzy, to set some expectation into the future. All right, any questions so far? I have time for kind of maybe one before we move on. All right. Oh, and thanks for the kind comment about you like my dog. Yes, I liked him too. He's no longer with us, but he got to live to a very ripe old age. Let's see here. Yes, they are a small breed. All right, so let's talk about release management now. It's very normal that people outside the team are going to want to know, when am I going to get my stuff? It's all well and good for us to say estimates are fuzzy, they're relative, there's lots of unknowns, they're not promises. But I'm sure many of you, like I have many times, exist in organizations where people are used to knowing stuff about the future, or at least pretending that we do. So let's talk about using these estimates in the fuzzy context of, or at least fuzzy estimates in the context of release planning. What we don't want when we think about release plans is to inadvertently give people a false sense of surety about the future. A release plan, a product roadmap is not a Microsoft project Gantt chart. They're not typically very useful, I think, even in waterfall contexts, but especially not in the Agile context of, say, a Scrum team, partly because people are used to interpreting them as promises. That's problem number one. Problem number two, they're really annoying to set up. They take a lot of time to build, they take a lot of time to maintain, and they're not great as a communication tool. They don't help us have conversations about what do we need to pull into or out of the release, because they dive immediately from very high level all the way down to the weeds, not very useful. Instead, typically when we're talking about trying to lay out release plans into the future, we're talking about some lighter weight thing, like a product roadmap. This particular format is called a goal-oriented product roadmap. It's just one example, where what we're doing is communicating to somebody, we are trying to meet some kind of concrete objective. We're trying to prove something, like a particular new piece of technology works, or we're trying to prove that we've reached some milestone, like we've hit some kind of critical mass of initial customers or something, or whatever it is. We then are guessing, probably the product owner, if we're talking about Scrum team, is guessing at what features and capabilities need to exist for us to hit that goal. And then we might spell out some metrics. Once we've done that kind of hard work of planning, what do we think is in the next release, we can start to set some expectations. So for example, this is what's called a release burn down chart. And the goal of it is to have conversations about where are we at? Are we going to finish a certain amount of things in a certain amount of time? So here we have 4 big goals that we would like to hit in the next release, A, B, C, and D. We get teams to do relative estimating for all the backlog items inside of those. Let's say they're using story points. We add up the story points for everything and all the goals. That gives me the height of the burn down. And if the goal is to finish all these things in 5 sprints, I can set a forecast from there. What I would then do is every time we finish a sprint, count up how much work is still not done. That gives me my burn down line. And I can start using that actual burn down to make forecasts. Now, in general, if the red burn down is below the dashed forecast, we're early. If it's above the dashed line, we're late. So looking at this chart, after sprints 1 and 2, well, it looks like we're in pretty good shape. We're going to finish all that stuff in 5 sprints, which is what everybody wanted. Hooray. But then after we finish sprint 3, now we're back above the forecast. Uh-oh, maybe we won't. After sprint 4, oh yeah, we are definitely not going to finish all that stuff in 5 sprints. So what do we do now? What are the choices available to us? Really, the product owner has kind of 2 levers here. Anybody know what they are?
Scope.
Yep,
Quality.
that's one. Yeah, scope and time. That's basically it. We can cut scope or we can add time. Which one of those choices gets made probably depends a lot on what expectations were met and when we plan this release up front, because we can be fixed scope planners or we can be fixed schedule planners, but we can't do both without lying. You have to pick one or the other. Fixed schedule planning tends to look like this. We have only so much time, so we're trying to guess what'll fit into the time that we have. So let's say that this particular team has a velocity of about 30 points. That means they typically finish about 30 points of work per sprint. And they want to release in 4 sprints. Well, that means they've got a capacity in that release of about 120 points. Now the estimates are fuzzy. If they plan 121 points, probably the world won't end. That might still be reasonable. But 200 points is not going to fit in 4 sprints. 120 is about where they're at. So they estimate all the backlog items and their product owner finds out this, well, all of A will fit and some of B in that time. Okay. Now we've got a choice. We could do all of A now and some of B now and deliver some of B now and the rest later. That's one choice. We could split B, basically. Or we could do all of A now and some of B now, but hold back B until the rest of B is done, which is not usually my first choice, but maybe makes sense sometimes. Or we could swap out. We could say, let's do all of A, and instead of some of B, maybe we do all of C, or maybe all of D will fit, and that makes more sense. But still, there's only so much space. Whoever is making choices about what's in the release can allocate the space they have, but they can't make more space. That's fixed schedule release planning. Fixed scope release planning, on the other hand, is maybe a little more intuitive. That's saying we're going to release when all of A and all of B are done, whenever that is. Now, we know that's about 150 points of work total, based on the team's estimates. And the team has been doing about 30 points a sprint lately. That means we think right now we'll get there in 5 sprints. If our understanding of any of the size of the backlog items changes, that might change our guess about how many sprints we'll need. But that's basically the difference. We can do one or the other. To do that in real life often feels a little bit like this. So Here I've got an ordered product backlog with sizes. This team has been estimating things in points. You see the point estimates on the cards there. And I have some numbers for velocity here. And to make a guess about planning a fixed schedule release, they're going to use an approach called yesterday's weather. So they figure out their average velocity for the last 3 sprints. That's about 21 points on average. They multiply that number by how many sprints they have, 4. That gives us this capacity of about 84 points. Then they look at their backlog and they say, well, in 84 points, we can do this and 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 this, all the way down to here. All of those things together is 81 points of stuff. Now, this 13 is too big. I can't fit that 13 in 2. Maybe one of these 3s, that brings me exactly to 84, might be reasonable. However, the product owner or whoever is making this choice might also decide, even if it would fit, it doesn't really make sense to do that 83 right now when these things aren't done yet. So I'm going to hold that back even though it could fit. The goal here is not to Tetris the release. It's not just to shove in stuff to hit the number. The goal is to come up with a valuable plan that makes sense, that is meeting an objective that seems like a practical amount of work to do in the time that we have. That's our goal. We could make some other changes. If this 13 point is really important to me, maybe I swap it out for a couple other things. Maybe these can wait and I put this one in, you know, whatever it is. But for us, let's say that this is a reasonable plan, these things. Now, here's what I don't want to do. Let's say that we decide that all these things are a reasonable amount of stuff to get done, 20 all the way down to this 8-point item. Why shouldn't I just start attributing them throughout the 4 sprints that I've had here? Why shouldn't I plan out all of my sprints in advance? Anybody know?
Because you probably won't finish it.
Because stuff might happen. Just because it's a reasonable plan today doesn't mean it always is. So let's say I start planning out my sprint. I've got this 20-point item that's awfully big. I could maybe fit in this little 1.2. Okay. What if they don't get this done? What do? Well, we re-estimate how much work is left. So this 1-point item is done. Hooray. This 20-point item is not done. So we would re-estimate how much work is left. The team thinks it's now a 5. It's still important, though. We'll put it back in the product backlog. Maybe it gets finished another time. But we're not done. The product owner or whoever is making choices about scope for this particular fixed schedule release now needs to figure out, is this a reasonable amount of work to finish in the time that we have left? What was their velocity from the sprint? It was 1 point. That's not a lot of time. That's not a lot of velocity. Because we don't get full credit, or rather we only get credit for things that are totally done at the end of the sprint. So what does that do to the rest of this? Well, velocity this last sprint is 1. So 24, what is that? 34, 42. 42 points divided by 3 is what, 14? That's a huge drop. 14 points times our 3 remaining sprints, 42. Apologies if my math is a little off. I'm going fast here. But we start adding up 5, 18, 26, 39. Oh, 44. That's maybe all it could fit now. We're going to have to push the rest of this stuff out of the release because we just got a lot slower as a team. The rest of these things won't fit. So what's going to happen in sprint 2? Well, probably something around 14 points is a guess. So maybe this 13, maybe we try for this 5 too. They both get done. Hooray, now our velocity is 18. Well, that's going to pull up our number a little bit. Maybe we clawed back some time and we can pull another thing in. So that's an illustration a bit of how we can plan a release with these fuzzy numbers but then also how we would actively manage it sprint to sprint using the same fuzzy numbers. Questions about any of that? I know we're kind of going a million miles an hour here at a high level. All right, well, that's pretty much all I think I have for you today in terms of planning. Let's see here. Share my screen again for the closeout bits. All right, so again, this is me. If you do the socials, by all means, reach out and find me on Mastodon at Bowtie Agility. I'm also on LinkedIn, Dr. Patrick McConnell. If you've got questions about this stuff, or you're looking for Agile coaching help, or you've got questions about Agile training or whatever else, by all means, reach out. We'd be happy to set up some time to chat with you. Also, please consider giving NextUp a follow on all of the socials, particularly LinkedIn. We post great blog articles, and of course, we do these monthly webinars, which are both a great free way to learn stuff and a cheap way to earn Scrum education units or PDUs for PMI or any other kind of continuing education credits you might need to maintain credentials. With that, I'm happy to hang out here for the remaining minutes. If there's anything else that you want to chat about or any questions about any of the stuff we talked about, I'd be happy to help you out. So thanks for coming, everybody.
Thank you.
Thank you.
Thank you.
Thanks.